So, thank you for having me here, and I want to thank Dr. Dhirensha and Sims for inviting me. And on the outset, I have to mention that Dr. Sandeep Batawa and Dr. Ravi Kumar and the entire team at Global for constantly throwing me at different challenges and giving me the right motivation. Without them, I won't be here today. So thank you for the entire team. The major challenge most of the physicians you face is that identifying the therapeutic window. Can't give more, can't give less. So you have to find the exact optimal dosage of immunosuppressors. So at least there are 3 different tests that are available. One is the Cylex, the other one is a Quantiferon based assay, and then the Toctinovirus based assay. So Cylex based assay has been there in the market for quite a long time. So what I'm going to do now is explain briefly about each of these assays, how they are done, and how to interpret, and how to take this in your clinical practice. Cylex and Quantiferon assays are almost similar. Right? In case of Cylex, you are once you give me the blood samples, I will add an activator called as phytohemagglutinin. So once you add the phytohemagglutinin, it will activate the T cells and starts producing the ATP molecules. In case of Quantiferon, instead of phytohemagglutinin, I'll add TLR7, and again I incubate the cells, and the T cells, they start producing interferon gamma. Now all I have to do is quantify how much of ATP has been produced or the interferon gamma has been produced. So there are nice equipments like luminescence, luminometer, and ELISA that detects fluorescent signals. And based on that, I can quantify how much of ATP has been produced or interferon gamma has been produced. Both of them, they read the T cell function. Now, how are we going to interpret this data? Immunosuppression and the T cell population are inversely proportional. Higher the immunosuppression, lower the T cells. Right? So, the rule of the game is very simple. Higher immunosuppression, lesser T cell count, lesser ATP, interferon gamma. If immunosuppression is less, you'll get higher T cell count, higher ATP. So simple, right? So taking this into clinical practice, so if a patient has a very high ATP signal, right? So more than 525 nanogram per ml, then it means there's a probability of rejection because there was a poor suppression. Since the suppression was poor, there were more T cells, and hence you're detecting more ATP. Similarly, if the amount of ATP is very less, then chances of him getting an infection is very high because higher suppression, lower T cells, lower ATP. So this is the optimal window that you are looking for. This data is actually true data that came from this publication. An equivalent data for Quantiferon is not available yet because it is still a test that's under development. The next one is a Toctinovirus. So this test was brought in by Dr. Vijil from Dr. Sandeep's team as well. So these are small DNA viruses. Most of us have it. I have it. I have checked my blood and I have it. And at least like 90% of the population I have it. I have checked even several of the transplant samples they give me, and most of them have it. Okay. So once you give me the blood samples, how am I going to process? So I can take these virus, extract the virus from either the whole blood or the plasma also, right? So I can extract, there are specific viral DNA extraction kits. I can extract it, and then I can quantify how much of the virus is present in a given sample. Okay. Now, how to interpret this data? Immunosuppression and the TTV. TTV stands for Toctinovirus. So immunosuppression and the virus load are directly proportional. Means higher immunosuppression, higher TTV. In case of Cylex and Quantiferon, it was inversely proportional. Here it is directly proportional. So again, the rule of the game here is very simple. So higher immunosuppression, lesser T cell count, lesser antiviral defense. So that's why you will see more virus. So because the viral defense is less, you're seeing more virus. So if the immunosuppression is less, it will lead to higher T cell count, higher anti-defense, viral defense, lower TTV or titer. Okay. So how are we going to interpret this in clinical setup? So if you detect a very high copy of viral titer, then there's a chance of infection is very high because higher suppression, lower T cells, lower antiviral defense, higher TTV titer. The reverse is here, right? So if the copy number is very less, the chances of rejection is higher. So this is your optimal window. So now we have 3 different tests. All look for the T cell counts. So which one is the best? So as a scientist, I have done a preliminary study on Cylex assay in Quantiferon. One issue that I face is that, so the blood sample has to be transported at ambient temperature. So it cannot be chilled, it cannot be frozen, right? So that is a major challenge in a tropical country like ours. And then added to that is the cost. I'm 100% dependent on the kits here, right? So that increases the cost of these tests. So my bet is going to be on the TTV titer assay because there are several advantages in this. The viruses will stop replicating once after the blood collection because it will reach a stationary phase. Blood is easy to transport. You can transport it at probably at room temperature and it can stay like that for at least 2 days. Best of all, it is cost effective. Okay. So you augment this TTV assay with cell-free DNA test or cell-free RNA test. Then your data is going, the report that you're going to get is going to be rock solid. Right? So a little bit about cfDNA test. Dr. Jignesh Patel already mentioned about cfDNA. So imagine a transplanted organ undergoing failure. Okay, so those cells that are undergoing failure, they are dying. It's called apoptosis, right? So they will wither out into the bloodstream, and the cell membrane breaks open, and the DNA content is released into the plasma. So the DNA is no longer inside the cell. That's why you call this as a cell-free DNA test. Okay. So once the blood sample reaches my lab, so I will collect the cell-free DNA from the plasma. I'll extract the cell-free DNA and then quantify by a very simple protocol, a real-time PCR. So I am quantifying a donor-derived DNA markers, okay? Because cell-free DNA can increase for a variety of reasons apart from rejection. An infection episode can increase the cell-free DNA, diabetes, any metabolic disorders, or even strenuous exercise itself can increase the amount of cell-free DNA. So I have to know very precisely how much of this cell-free DNA is actually coming from the donor organ itself. That is very important. So that technology I have developed. There are, so this is data from a pilot study that I did with Dr. Ramanathan from Frontier Life Sciences. I was blinded to the samples. Now as you can see, whenever there is a indication for your rejection, the amount of cell-free DNA is also increasing. Okay. So I am also focusing on something called cell-free RNA. There's also a very good correlation right now, and my future bet is going to be on cell-free RNA. It's very difficult to extract and play around with cell-free RNA, but my bet is going to be on that in the future. So if you compare my technology with the current technology, right, most of the current commercially available arrays are not Indian-specific polymorphisms, right? So I have an array that is Indian-specific, that screens for Indian-specific polymorphisms. And the commercial technologies that are available, they screen for more than 266 SNPs at least, and it costs upwards of 38,000, and they take a minimum of 1 week, 2 weeks to give you the report. So in my case, the cost is comes down. It's probably, I just wrote it for the namesake, but it may be slightly more or slightly less. But I give the report in 24 hours. Right. So if there is a suspicion for the rejection, it's time to start working on that. Right. So a model of future report would look something like this. Right. So you have a CYP3A5 metabolizer report, so which indicates the patient requires a higher dosage of tacrolimus, and you have a report from the cell-free DNA. So this is an actual report. Like on April 17th, the sample was given. I was blinded. I didn't know whose sample was what. So April 17th, the first sample came. The cell-free DNA amount was very high, and then 10 days later, you see there is a very good decrease. So you can be very confident that the organ is undergoing stabilization. Right. And then you added to that, you have the Quantiferon assay and then toctinovirus, and you know that there is an optimal immunosuppression. So this report tells you that yes, you are giving the right dosage of tacrolimus. The organ is stable, and you are giving, you're attaining optimal suppression in the patient. We don't have to worry about over suppression or under suppression. Optimal suppression, right? So any aberration you see either in the cfDNA or in this one will definitely indicate some issue in the system of the patient, right? So when these kind of reports, when they go to the lab, so I always make sure that they're 100% perfect, accurate, right? So the take-home message is that all these Cylex, Quantiferon, TTV assays may be used as an indicator to determine the accuracy of your immunosuppression. And if you add the cfDNA, cfDRNA test, probably it's going to augment the sensitivity, specificity, and accuracy. Having said that, I want to propose that we form a kind of a national alliance for heart and lung transplant genomics, because it will help to all these tests, like I didn't know one, right? So it was developed because of the input that I got it from the transplant team. So if you have this kind of an alliance, right, for research alliance, then probably it will bring in all the like-minded clinicians. We'll get more ideas. It will help us to apply for grants, and we can develop much more affordable and applicable tests, right? So if you're interested, probably you can contact me, and probably we can start working together. And all these tests right now, I'm doing the cell-free DNA component and toctinovirus. All these I don't charge right now because I want to have a database for at least like 25 to at least 50 samples matched with biopsy reports before going into the commercial aspect. So if I think I have received at least 25 samples from the global team, and since the test is really free, and if some of you is interested, probably you can contact me. Because the blood sample has to be collected in a specialized tube. It's called Paxogene tubes. So the cost of one tube is 1,200 rupees, but you can transport the blood at room temperature. Okay, so I know the composition of the ingredients, so I'm collaborating with an chemist in IIT Chennai. So we will soon come up with our own proprietary tubes, so that will reduce the cost of the tubes further, right? So I want to call myself as a specialist in developing affordable genomic technologies, right? So if you're interested, please, you can anytime collaborate with me. Thank you.